think we're starting. This is Sandra again with Real World Learners, and I wanted to take a minute to come on today and talk about what it means. I've mentioned several times we're working on math strategies, not just math facts. So I wanted to take a minute and give you an example so you can work through this and see exactly what we're talking about here from one of each of the 4 operations. So before I dive in, and I have a little example here, I'll be giving you a quick math lesson. Just for anybody who hasn't seen yet, we have the Framework Math series, Laying the Foundation, which is all about helping kids learn how to use the Rec and Rec and 10 frames. So just 2 hands-on manipulatives, but those 2 give you the most leverage for getting a really solid conceptual understanding of how numbers work and what they are. So we use those 2 throughout the entire series, and this simple tool can get you all the way up through what we need to do with multi-digit multiplication, long division. The principles we lay with a single-digit facts stretch to all of them. So you've probably heard me talk about the addition book, that it covers sums from 1 to 1 million. Because what we do, about half of the book covers the single-digit facts, and then we stretch those strategies to get kids really comfortable and confident with working with any size numbers. So it doesn't actually cap out at 1 million. It just gives kids the strategies to add anything confidently. So the basic premise is that we're following hands-on, so tactile, touching things, to pictures of those. So they have the pictorial representations of that. And then moving into the abstract, where they're just working with numbers on paper. And a lot of math curriculums jump straight into that part where they're just working with the numbers on paper. And that's where a lot of kids stumble and get held up, because they don't have the really concrete and visual representation of what those concepts are. So we want to start at the beginning, no matter how old kids are, whether we're filling in gaps or whether we're laying a solid foundation. Give them the experience of making, touching, building, taking apart numbers to build that foundation of number sense. Okay, and then as we get into each of the core books, so addition is out, multiplication is in the works, should be released soon, and then subtraction kind of piggybacks on addition, division kind of piggybacks on multiplication. So those will be slightly more minor than these 2 cornerstone books, addition and multiplication. Okay, so we want to, I just want to talk briefly today about what the key difference is here. So this is not a series that just helps you memorize math facts. Okay, there's a lot of curriculums out there that focus on songs or tricks or different things to memorize the single-digit facts. And I've talked at length in several different videos, so you can find those, about why that's actually not a good idea. It doesn't give kids a chance to really enter into and understand how math works, and it doesn't allow them to stretch it. Okay, it just gives them those facts, which work as long as they remember them, but it doesn't stretch. So I wanted to talk, actually, I realized I haven't really given you that many examples of what this means. So I want to be really clear, give you an example. I'm not going to do the whole hands-on and then visual and then abstract. The books will do all of that. But for parents or if you want to bring the kids and watch this, we're going to do a little math lesson here. We're going to jump straight into the numbers, but we're going to talk about how a single-digit strategy stretches to work with multi-digits, and we'll just do one example, from each of these. Okay, so I'm going to switch my screen here, and let's dive in. Okay, so for example, with addition, when we're doing single-digit facts, we talk about 9 plus 7, for example. And one of the strategies, there's 4 key strategies for addition and 2 bonus strategies that are built around doubles. So once kids really get a grasp on those 4 strategies, they'll realize it helps them make a lot of connections and gives them the power to think flexibly about numbers. So it puts them in control of what they're doing with math, so that the math is not in control of them. And so they're not just like left to the mercy of people giving them the answers, or falling into the am I right trap. As a math teacher, that was the most often asked question, besides Miss Bilisky, that am I right? So we want to give kids the confidence to know, is it a reasonable answer? Do you know if you're right? Okay, so let's do the math. So 9 plus 7, one strategy is to change this, and they'll get the hands-on experience to see what this means. into 10, and then the 7 becomes a 6 because we're moving 1 up. Okay, so 10 plus 6, and then you can subitize that. We know that 10 and 6 is 16. So all of that is built up in the beginning books and the beginning levels. But this is where we stretch it. So if you know that with a 9, you can just take a number off and give it to the other one, then you can do something like, this can be any variety of question, but 89 plus 17, you can do that in your head if you understand the principle that you can simply take 1 away from the 17. So we can call that 90 plus 16. So then you have 90 and 10 more, it's kind of a hidden strategy in here, is 100. And then you have 6 more. So we have 106. Okay, let's jump over to multiplication. Of course, this is one little tiny picture out of a lot of different addition strategies. But I want to show you how the single digit facts stretch to the any multi-digits, any size numbers. Okay, so what if we're looking at 5 times 8? Okay, the default way that kids usually learn how to multiply by 5 is they skip count by 5s. And skip counting by 5s is easy to do. It rhymes because they all end in 5 or 0. And it's kind of habitual. But if you can break them out of that and help them think about what's actually happening, if you're doing groups of 5s, let's say I'm going to actually break this out here. Let's say you're doing 5 times 3 on a Reckon Rec. You want kids to see that, 3 times 5. 3 groups of 5 is exactly half of 3 groups of 10. So once they see that and get a really good handle on that, then they'll own that strategy and they'll know anytime you're doing a times 5, first do a times 10 and then break it in half. Okay? So if they see it, you don't have to worry about a lot of formulas or words to do it because they just see it. It makes sense to them. So instead of doing 5 times 8, we're going to do 10 times 8 because we know that that is 80. And then we cut it in half. So we know 5 times 8 is 40. Okay, you certainly could get there by skip counting fairly quickly, but you couldn't do skip counting for 5 times 84. But if you know the strategy, this is where the magic comes in, then you know, okay, let's not do 5 times 84, let's do 10 times 84. And that's another trick in its, not trick, that's another strategy in itself. We don't want to just say add a 0 because adding a 0 gives you nothing, but you want to show them how multiplying by 10 moves it up a place value. Hidden lesson inside a lesson there. And then, okay, so you multiply by 10 and then you cut it in half. So we have 420. So this, if kids come into this already knowing their single digit facts, it may be a hard sell, sometimes it is, to get them to slow down and think about 5 times 8 is 40, if you think about it this way. But if you can show them this strategy empowers you to do 5 times 84 in your head, and you will be amazing at math. That's usually pretty exciting to kids. I know it's exciting to me still, but I am a math teacher. Okay, so let's jump down here to 27 minus 18. Making sure I'm on the right screen, yes. Okay, so 27 minus 18, let's kind of just talk through what you would do. This isn't single digit. There's different strategies for single digits. But what if we have double digits? Okay, so one way to think about it is with an open number line. You may have heard of this. We'll start off at 27. And again, this is kind of far down the road. We lead kids up through this, but for a short preview lesson, I wanted to just jump into this. Okay, now you want to take away 18. So what I would do is take away 10, so you get to 17. And then you need to take away 8 more. So an easy way, if they really have a flexible understanding of numbers, is to take away another, it's not proportional because they ran out of room, another 10, so you get to 7, and then jump back up 2 spaces because you kind of overcompensated. So you end up at 9. Okay, there's other ways you can start at 18 and do jumps up to 27. That way it feels more like adding and less like subtracting, so it's a little more familiar. But let's take that strategy with the open number line and see how it's really powerful to do an example of 3-digit subtraction with borrowing. So let's say we're doing 384 minus 177. Looking at how I did this in my notes here. So let's say we start off at, what did I do? Okay, let's say we start off this time at the bottom, and we'll turn it into a more comfortable adding kind of situation. Okay, so I'm going to go in really friendly number jumps. So I'm going to jump up, we want to jump up 384 spaces. I'm going to do that little pieces. So I'm going to jump up 100 spaces. Okay, that puts me at 277. And then you could do 300 at once if you want to, but 100 more is 377. 100 more, so you can literally see the 300 there, is 477. Okay, as I'm doing this, I'm realizing my notes and what I'm doing are not right, and I'm on a live, so I can't fix it. This is completely not right, and if I get a chance to edit the video, I will do that. Sorry if anybody was watching. Even for a math teacher, it's a little bit hard to do this on air. Hold on, bear with me 1 second. That would be a good lesson if you were adding. That's not what we're doing here. I sincerely apologize, but let's fix it. Let's fix it. Okay. We want to know how many jumps does it take to get to 384. Okay, so here's an example of if you're working with your kids, they might go through this thinking process and realize what's going on. Okay, 177. How many jumps does it take to arrive at 384? Okay, so if we jump 100 spaces, we end up at 277. We're getting close to 384. We can fit in one more jump. That will get us to 377, and now we're super close. So now, if we go up, if it's not intuitive to see how to get from 77 to 84, you can jump to a friendly number. So 377, let's go up to 380. So that takes 3 steps. This is what I meant to do. I'm so sorry about that first part. And then up 4 more to get to 384. Okay, so now you can see you take 200 and 3 and 4. So 207 steps. I'm second guessing myself now to get to the right answer. Let's move on. Okay, 37 divided by 5. Now, this is where it gets, the math starts getting really real. I like to explain it, and this kind of comes after a whole unit on multiplication with the area model. We're going to kind of take that backwards and say, let's say we're tiling a long hallway, and I keep the story consistent so that it doesn't have new meanings every time. Okay, 37 divided by 5. Let's say we have a box of tiles with 37 tiles in it, and we want to lay 5 tiles at a time. So we're going to do friendly numbers and see how many tiles we can lay. Okay, if we have 5 rows, I'm going to pick benchmark numbers, 1, 5, or 10, or our go-to numbers. So if we have 5 rows of 5, that gets us to 25 tiles. And then we see, how many do we have left? Well, we can do, what if we did 2 more? 2 more would give us 10 tiles, 2 rows of 5. So we're getting really close. Now we have 35 tiles, but we need 37. So we have 2 extra tiles. So we would have 5 rows and 2 more rows, so that's 7 rows. And there's 2 extras, so we'd say 7 remainder 2. So if you do some kind of long division this way, you don't have to separate cases that don't have a remainder and cases that do. You just do the whole process, and it either works out perfectly or there's a remainder, but kids get a pretty intuitive sense of how to do it. Okay, and then stretch that strategy to here. So let's say we're tiling a long hallway with 5 tiles in each. This time we have a delivery of 354 tiles. Okay, so we're going to use benchmark numbers 1, 5, or 10, and our 10 we're going to stretch it to 100. So if we were to do 5 times 100, that would be 500 tiles, just too much. So let's cut it in half. We're not going to worry about all the in-between numbers. We're just going to cut that 100 in half. So we're going to do 50 rows of 5. Okay, so that, if we know this one, we know it's 250 tiles. And then we're getting close. Let's add on another 20. So that's just like this one. Now we have 100. Okay, so now we're at 350, and we haven't done anything difficult. We've just used benchmark numbers that were really, really easy to figure out. Okay, so we have 350, and we only need 4 more. If we're doing 5 tiles per row, we can't do a whole nother row, so it's a remainder 4. So 50 and 20 is 70 rows, and there's a remainder of 4. Okay, so there's your math lesson with real life stumbling on a live video. There you go. Okay, so if you made it this far, congratulations on listening to a pretty intense morning math video. And if you have any questions about the books or anything that we're doing with Framework Math, let us know. I'll be cycling back to answer any questions. You can click the hashtag to see any videos that all of the posts that I've done this week. And we will be choosing one person Sunday night from any of the comments to receive these first 2 books. I will send those to you. All right, thank you for joining me. It's been really fun this week talking with all of you, and I will see you later.